Okay, now we're just continuing on. Now we're going to do limits at infinity. So meaning here, the limit, instead of x going to some number, now we're actually going in the x direction. We're going to infinity. F of x is equal to some number. If you get an answer like this, when you go to infinity, some answer here, you have that's absolutely right, a horizontal asymptote. So that's big, right? That's important. Horizontal asymptote is the limit when x goes to infinity. Vertical asymptote, which we just did, right, was when our y value or our f of x value went to infinity. Okay. All right, so let's do some examples here. So let's go back to our other example. Example 1. Now we did limit as x goes to positive infinity of 3x minus 2. Okay, and this is going to be a little bit weird, right? Now I'm going to ask you to do something totally strange. I'm going to say, do your direct substitution, but do it with infinity. So I'm going to say, plug in infinity. And you guys are going to say, Mrs. Arwen, you can't plug in infinity, right? But you can think of infinity as a really, really large number, right? Okay, so if we've got 3 over infinity minus 2, well, infinity is a really, really big number. It doesn't really matter that we're subtracting 2. So this is actually just 3 over infinity. And if you think of this 3 over infinity, let's say I can't really think of infinity. I say it's like a million, okay? That's kind of like infinity for me, because if I had $1 million, that would be so awesome, right? So 3 over a million, this is a very, very, very small fraction, right? Very small fraction. And if that denominator keeps getting bigger, which infinity does, this fraction is going to go to 0. Yeah, you guys guessed it. So it's just going to keep getting smaller and smaller and smaller as this number gets bigger and bigger and bigger. Okay? All right, so that means that our limit actually equals 0. So we do have a limit. It's 0. So we have a horizontal asymptote at y equals 0. And I already drew this. We knew we had vertical asymptote at 2, right? X equals 2. And now we have the horizontal asymptote at y equals 0. And we already kind of sort of sketched this graph so you knew what it looked like, of course. There we go. And you guys can see also that it didn't really matter whether we went to positive infinity or negative infinity. You can't have negative 0, right? So that's why if we're going out here towards negative infinity or positive infinity, it didn't make any difference. And that's typically going to be the case when you have a polynomial. Okay? All right, exponential functions work slightly differently. So let's talk about that. So exponential functions. Because it really does matter for positive and negative infinity for exponential functions. Because if you have a number going to infinity in your number here any positive number here for b. B is any number, right? And you have an infinite number in x. Well, that's going to be really large, really, really, really large number, right? So this is like, for example, like, let's do 2 to the infinity, right? And that's obviously going to be very, very, very large, right? Because it's exponential. Now, what happens when you take that, though, and you go to negative infinity? When you have a negative number in the exponent, what does that mean? Well, it means this. So let's say for example 2 to the negative infinity. Well, when we have a negative number, that puts it down in the denominator. So this would be 1 over 2 to the infinity, which is equal to 1 over infinity. And we just talked about that. If we stick in a really large number here, this whole fraction is going to go to 0, right? Yeah. So when we're thinking about exponential functions, it really does matter whether we're going to infinity or negative infinity. So because this one goes to 0, it's like opposite. Okay. All right. Quick example, and then I'll leave you to it. Okay. So let's find both horizontal asymptotes and vertical asymptotes for an exponential function. So example 2 here. So find horizontal asymptote and vertical asymptote. Okay, so horizontal asymptote, we're going to take the, oh, I need to give you the function. F of x is equal to 5e to the x. That's our favorite. E to the x is our favorite exponential function, right? 7e to the x minus 3. Okay, so we're going to make that a little bit complicated, right? Okay, so for horizontal asymptote exponential functions, we check both positive infinity oh, darn it. Sorry about that. E to the x plus 2, and then 7e to the x minus 3. Okay, and then we have to check the negative infinity, right? Okay, so 5e to the x plus 2, 7e to the x minus 3. Okay, so we're going to do a horizontal asymptote first. Okay, so if I do a direct substitution and we plug in infinity, right? Infinity, these two numbers are going to get very, very, very large. And then infinity plus 2 is not going to make that big of a difference, right? Or infinity minus 3. So these numbers, when we're going to infinity, become insignificant. Insignificant. They're too small, okay? They don't make a difference, okay? So we can say this is the same thing as the limit as x goes to infinity of 5e to the x over 7e to the x. Well, now, algebraically, we can just simplify this. What happens to the e's to the x's? Yeah, you're right. We can just cancel them, right? And so this goes to 5/7. So sure enough, we've got a horizontal asymptote, right? Y equals 5/7. That's one horizontal asymptote. Okay, and we know something different is going to happen when we go to negative infinity here, right? So we're going to plug in negative infinity. Now, these two numbers go to 0 because this will be 1 over e to the infinity, right? So remember that e to the negative infinity is equal to 1 over e to the infinity, which goes to 0. So now these become 0, become insignificant, right? So we're just going to cross those out. They go to 0. And the 2/3 becomes really significant because this goes to 0. So this will become equal to negative 2/3. That's how we get those two horizontal asymptotes for exponential functions. Okay, and then let's talk about let's not forget our vertical asymptote, because we know how to do it from the last video, right? First step, yep, you got it. Set the denominator equal to 0. Whoa, can we do that? An exponential function? Yeah, we can do that. It's no big deal, right? You learned this in pre-calc. We're going to add our 3 over, divide by 7. So we have e to the x is equal to 3/7. Oh my gosh, how do we solve this? So complicated, right? Now we're going to ln it, right? So we ln, oh, for goodness sakes, I can't ln it, but we'll try ln, and we'll squeeze in an ln there. What happens to ln and e? You're right, they cancel, right? So we get x is equal to ln of 3/7. Can we leave it like that? Absolutely, that's our vertical asymptote. Yep. Good job, you guys. Thank you.